Is that okay? Just do capacitor circuits. Now you're going to have other types of circuits, but you'll find that the resistor circuits, they work a lot like the capacitor circuits. Like the skills that you build in doing the capacitor circuits will translate into resistors. So I picked some that were more difficult, and as I told you, the ones that you have on the old exams, but they tend to be a little easier, but the ones that you have on your free response will be more like some of these, although not like this one. I just thought we'd start with this one. This one's a little simpler. In fact, we might have done one like this already. In fact, you might be able to just tell me what are the voltages right off on this one. You think you can? Take a look at it and tell me what you think. I would know that the 4 and the 4 here, they combine to give me a 2, and then the 2 and the 1 would combine to give me a 3, and then I have a 3 and 6 in series, and that's going to give me a 2. So the equivalent is 2. So can you tell me what is the voltage on this 6 microfarad capacitor? 4 volts. Because it's I'm going to show you in a minute. So because it's a 6 and a 3, and the bigger capacitor is going to have the smaller voltage. And so what's the voltage going to be here? Now I have 4 volts here. I have 8 volts across this whole business. So what's my voltage here? 4 volts. 4 volts. And here? 8.
Could you draw it down to?
I'm about to, yeah. So first thing I want to do is to take this and figure out what is the equivalent. That's 1 over 4 plus 1 over 4. That's equal to 2. And so that's going to be my 12-volt battery, 6 microfarads. Let's sort of redraw this a little bit differently.
And this is number 5 slide.
Oh, I don't know. Yeah, number 5. And so this is 6 microfarads, 2, 1. And then I take this part, 2 plus 1, gives me 6 and 3 microfarads, 12 volts. And then I take those two, which are in series, and that's going to be a 2 microfarad capacitor. So that's my equivalent. That's 12 volts. And then I find the charge on that capacitor is going to be 24 microcoulombs. Remember, Q equals CV. So 24 microcoulombs. That means I have 24 microcoulombs here and 24 microcoulombs here. Now I have the charge and the capacitance. So I can say V is equal to Q divided by C. So that gives me 4 volts and 8 volts. But notice the big capacitor has the small voltage, the small capacitor has the big voltage because they're inversely related. So I'm done with this one. This has 4 volts and 4 volts. But now I need to deal with this other parallel branch. Capacitors in parallel have the same voltage. So whatever voltage I have here, I will also have here and here. 8 volts and 8 volts. Then, I'm almost done. I have 8 volts here because that carried over from this capacitor. Then I look at these 2 capacitors and I know that they share 8 volts, or they split it up rather. But because they're identical capacitors, I don't have to go through the same thing that I did down here where I have to figure out the charge and then jump over and figure out the voltage. Because I know if they're identical, they have the same voltage, and it has to add up. So that's 4 volts and 4 volts. I think we did this problem actually in class, but it's a good one to start with. Okay?
So 2 is microfarads.
I don't know what you mean.
The 2 calculated is microfarad.
Yeah, that's the equivalent capacitance.
And you calculate the voltage by doing what?
The voltage is Q over C. All right. Let's look at some of these that are more complex. Like, let's look at this one, for example. So on this one, I have, it looks a little bit different, but what I have is, I follow along, I come to a junction. This is on page 4. I come to a junction, and then I notice that I have 3 parallel branches. And then that junction all comes back together, and it splits up again. So the way that I would draw this one, remember, coming through here, I see my junction that splits into 3 different parts. So I have my battery, and it splits into 3 parts. And then in the first part, I have that 3 microfarad capacitor. In the second part, I have a 3 and a 6. And then in the third part, I have a 6. So this is 3 microfarads, 6 microfarads, 6 microfarads. And then it all comes back together, because if there's no devices in between, this point on the wire is the same as this point, is the same as this point. I can squeeze all this down just to a single point. And that's what I do here, is I squeeze it down to a single point, and then I break it into another parallel branch. And this parallel branch will have how many branches?
2.
It'll have 2. I have this one right here and this one right here. So I have a 4 and a 4 in series, and I have a 2 in parallel with that 4 and 4. And that's all 12 volts. Now, I've set up the numbers here so it works out simply. Is that right? 3, 6. Yeah, I think so. 4 and a 4 in series. There are several places that I could start to find my equivalent. I could start here, or there are 2 places I could start. I could start here, or I could start here. I just do them both at the same time. The 4 and the 4 is what?
3 volts.
Huh?
3 volts.
No, a 4 and a 4 is 2. It's 1 over a quarter plus a quarter. That's equal to 2. You might want to make like a card. Again, you can always just do the fractions on the test, but you might want to make a card as you're going through and just say, oh, these are the common combinations of capacitors that he likes to use. And that way you'll know when you see a 4 and a 4 in series, like, oh, that's 2 microfarads. Just memorize those.
So whenever you see a capacitors in a series, the first thing to do is combine the capacitors.
The ones that are either only in series or only in parallel. And it depends on the circuit. We'll see them. Like right here, these are only in series. That's why I combine them to give me a 2 microfarad capacitor. And these are only in series, so I combine them to give me a 2 microfarad capacitor. And then I have parallel branches that have 3, 2, and 6, and a 2 and a 2 in parallel. And so I can do those. I'm just going to combine those and make it 2 in series. So this is the first one, and then this is the second parallel branch. 3, 2, and 6, gosh, I forget what that is. 1 over 3 plus 1 over 2 plus 1 over 6. Is that 2, 6 plus 3, 6 plus 1, 6? Oh, that's 1. So that's equal to 1.
It's in parallel.
Oh, yeah.
Together.
You're right.
So it'd be
You're
11,
right.
wouldn't it?
Yes, you're right. So that's 11. Yeah, this one doesn't work out easily. So 11 microfarads, and then I have a 2 and a 2. That's 1 microfarad, and this is 12 volts. Now,
It's 4 microfarads.
yes, you're right. 4 microfarads. I'm sorry.
Which combination of parallels are made?
Hmm?
Which combination of parallels are made?
Are made?
Could you circle like which ones were added up?
These 3 added up to be 11. 3, 2, and 6. And these 2, a 2 and a 2, added up equal to 4. And then you have to figure out what is the equivalent. That's 1 over 11 plus 1 over 4. I usually try to give easier numbers than this. I'm sorry, it's just this one I pulled up, it wasn't. That's equal to 2.9 microfarads. And so my final equivalent is 2.9 microfarads with 12 volts. So that tells me that the charge on that, 2.9 times 12, is 35 microcoulombs. That means that I have 35 microcoulombs here and 35 microcoulombs here. because capacitors in series have the same charge, and they have the same charge as uh, their equivalent capacitor. All right, now I can figure out the voltage. Remember, V is Q divided by C, so that's 35 over 11. It's 3.2. And then I can either do 35 over 4, that's 8.8, or I could say 12 minus 3.2. We've been doing that already, but it just seems like if I have 3.2 volts here, then I know that this has to be 12 minus that value. These values have to add up equal to 12. Now once I get that, I can begin writing in some things here. So if I have 3.2 volts here, I know I have 3.2 here, 3.2 here. And then across these two capacitors, I have 3.2 shared, or split rather. And we'll figure out what that split is. And then down here I have 8.8 volts. And then between these two capacitors, I have 8.8. So that tells me that the voltage on each of those is what? 4.4 and 4.4. Okay? Now, I want to figure out what is the voltage on these two capacitors. The way that I would do that is I know that I have 3.2 volts. Those have an equivalent of 2 microfarads. So they each have a charge of 6.4 microcoulombs. 6.4 microcoulombs. And so the voltage would be 6.4 divided by 3. That's 2.1 on the top one. And then it's going to be half of that, 1.1 on the bottom. 2.1 here, and 1.1 volts there. Yeah.
So Q is in microcoulombs and C is in microfarads.
Right. And that's normal, so we'll always do that. You won't need to change it to SI units.
It's kind of hard to, because C is the one that kind of throws me off with the coulombs and all.
Yeah, you got to be careful because the C in the units is coulombs, but C in variable is capacitance. So don't get your C's mixed up.
I just need to just these steps straight. So the first step of solving a combination of circuits. First, you combine capacitors by in series and parallel.
No, you combine whatever is smallest that is either just series or just parallel. Usually that's that you're dealing with series components within the circuit, but sometimes, and we did one in class like this, where the smallest part of the circuit that was purely series or parallel was a parallel circuit. And I'll try to find one for you.
And after the circuit is simplified by all the combinations, you find the charge in coulombs.
Right here, yeah.
So how'd you get 2.9?
2.9 is 1 over 11 plus 1 over 4, which is 2.9 right here. And then I'll find the charge on both. That's what we did over here. Find the charge on both. And then you calculate what is the voltage on both, the 3.2 and the 8.8, where the voltage is Q divided by C.
So basically calculating the net. So to find the coulomb, you calculate the net of those capacitors.
The equivalent of the capacitors, yeah. Let's do some more though. Like the more practice you do, the easier it'll be.
Well, just trying to comprehend all these.
I know, I understand, but let's do some more. All right. So let's see. Have we done one like this? I think we've done one like this. Let's do this one. This one's a little bit easier. I have a 12. Well, you look at it. What do you think? Can we do this in our heads? Maybe. Where am I going to start? The 1 and 2 are in parallel, right? And so 1 and 2 in parallel is what? Equivalent? 3, right? 1 plus 2 is 3. And so then I have a 3, a 6, and a 2 in series. So my equivalent circuit is a 3, a 6, and a 2. We've already done this one. 3, 6, 2 in series, what's that? 1 over a third plus a 6. I think we've done this one. Plus a half. That's 2, 6 plus a 6 plus 3, 6.
How come 6 is not in a series?
Hmm?
How come 6 is not in a series?
Not in a series.
Not like a whole graph.
I don't understand. What do you mean?
But 6 is not parallel to the 3, 2.
Oh, it's not parallel. This is a series circuit. So I start here. Actually, I misdrew this. This should be 2, 6, and 3. I start here. I go through. I don't come to a junction until right here. But I know that these two capacitors are equivalent to 3 microfarads.
The positions just seems like that 6 should be calculated as a series, and
It is in series.
The other two
Right.
capacitors should be just parallel.
And they are. Yes.
Why did you add them in there as if they were in a series?
I didn't. I just added them up. 1 plus 2 is 3.
Is 2 and 3 supposed to be added in a parallel?
No. Okay. So, what is this 362?
Because capacitor 1 looks like it's parallel to resistor 2.
It's not. It's in series. I come through. I don't find a junction until I get right here.
So parallel is the junction.
You have to have a junction to find parallel. Did y'all have this? What's 3, 6, and 2? It is 1? All right, good. So that's 1. That means that you can replace that circuit with a 1 microfarad capacitor, 12 volts. That means that I have 12 microcoulombs across it. That means that I have 12 microcoulombs here, 12 there, and 12 there. And then I can find the voltages. That's going to be 6, 2, and 4 volts. You could have guessed that, perhaps, because I know that they all have to add up equal to 12. I know that this is going to have the biggest, and it's going to be 3 times this one and 1.5 times that one, just looking at the distribution of the capacitors. But if you don't see that right off, that's okay. You just figure out what is the charge right here, and then carry that charge over into these 3 series capacitors, and then you can find the voltages. The voltages here are 6 volts, 2 volts, and 4 volts. And then we're basically done. This is 6 volts, this is 2 volts, and each of these is 4 volts because they're in parallel. Okay? Okay? Yes, sort of, kind of. More and more practice will help with it.
So why is the 12 carried over to those 12 microcoulombs carried over instead of changed like the previous example?
It wasn't changed in the previous example. Capacitors in series always have the same charge. These 3 are in series, so they have the same charge as the equivalent capacitor. Try another one? Is that okay? Is this helpful for you? See these different kinds? Okay. Well, we can talk about it. All right. Let's see. Could be. So come along here. I find a junction right here. Let's try redrawing this, okay? I always just take it one piece at a time. Don't worry about this mess off to the right now. So I have 2 branches here. One is 6 microfarads, and one has my 4. So that's my 4, and that's my 6, and I have 12 volts right there. Now, if I keep following this around, I know that I hit this one. So I have another 4 microfarad capacitor here. And then notice if I go back here, that I can go clear back to the battery without going through anything else. So I know that from this path, I'm going to have a clear path back to the battery from after that second 4 microfarad capacitor. But right here, if I keep going past the 6, I hit another junction. And notice that I have 2 capacitors off of that. That means that it's going to split again like that, where I have a 1 and a 2 microfarad capacitor.
Is this number 2?
This is page, yeah, this is page 1. You're right. And then those come back together, and then everything comes back together and goes to the battery. So this circuit, these are identical circuits. And you know what? I think that y'all can probably see this, right? Can you see this, what the voltages are? Because I have a 6 and a 3 and a 4 and 4 in series. They're in parallel with one another. So they're both going to carry 12 volts. Each of these branches are going to have 12 volts because they're in parallel. So I'm going to have what voltage here?
Can you pick your hand up?
All right, along with that 6, yes. And 6 here as well. And here I'm going to have the big or the small on the big capacitor? The small is right, because I'm going to have what? 4, and I'll have 8 and 8. See how easy that is? Like once you begin to see the relationships, they begin to fall out. So I have 6 volts here, 6 volts here, 8 volts here. No. Not 8 volts. Y'all said it right. I have 4 volts here, and 8 volts, and 8 volts. The hard part in these is getting from here to here. But I think once you see the circuit, then with some practice, and it'll take lots of practice, but with some practice you begin to see it more.
So why is the C4 and C5, why not in series?
The C4 and C5, the reason they're not in series is because, remember, I always start at my big side of my battery. And as I come through, I begin looking for junctions. And this is my first junction right here. My first junction occurs right here. I split into 2 parts. And then, as I travel along after this 6, then I come to another junction. And that's how I know that the C4 and the C5 are 2 different directions after that junction, which is the C4 and C5, that was the 1 and 2. So that's like right here. I have to go 2 different directions, in there to get the 2 and there to get to the 1. I know that's kind of hard to see, and honestly, if you try going back the other direction, you might not see it so readily. But always start at the big side of the battery and go in that direction, and you'll be able to see it more readily. I'll design the circuit so that you'll be able to see it better. Yeah.
So with the volts, how come the volts were not divided? So I'm saying coulombs.
Can you, what do you mean?
I just don't know how the voltage from scratch.
Oh, whereabouts? On the 6 and the 3? Yeah, so right here, this is the same as a 6 and a 3 in series. 6 microfarads, 3 microfarads. And across both of these, across the entire thing, I know that I have 12 volts. And so they have to add up to equal to 12 volts. Now I know that little branch has an equivalent of 2 microfarads. 2 microfarads, 12 volts, gives me 24 microcoulombs. So I know I have 24 microcoulombs here and 24 microcoulombs here. And since V is Q over C, then I know that I have 4 volts and 8 volts.
So 1/6 plus 1/3 divided by the reciprocal
Is 2. Right, 1 over 6. 1 over a 6 plus a third is 2. The 6 plus a third, that's 2 6 plus, or 1 6 plus 2 6 is 3 6. That's a half. 1 over a half is 2. We do another? Is that okay? Do another? Y'all look excited about this. Oh, I'm sorry. Are you excited? You look tired.
It's just 2 o'clock.
I understand. This is the way to get better, though. The more and more you practice, the easier and easier it'll be. In fact, you know what I would do is try to work through all of these on your own afterwards. We've worked one somewhere that we'll come back to it if we have time. Let's go look down at.
Can I finish writing down the answers for that?
Yeah. Is it number one?
Yeah.
All right. All right. Let's do this one. This one sort of looks funky, but it's not. It's not really that bad. I'm going to start at the big side. I'll start right here, and I'll come here. Let's go ahead and redraw that. I have my 100-volt battery. I go to my 20 microfarad capacitor, and then I come here. And I know that I split into that junction, and I sort of split into a second junction, but notice that I can expand this and redraw it as 3 different parallel branches. Not 2, but 3. Now see how that is? That splitting this up, I split it into 2 branches, but then immediately before I have any other devices, I split into 2 other branches. And that's the same as splitting into 3 branches. So I'd have the 2 microfarad, the 3 microfarad, and the 10 microfarad right there. And then further, have another 10, and then they all come back together again, and they go back to the battery. That's 100 volts.
It's not outside section.
Because there is no junction between that 10 and that 10. Those 2 capacitors, these 2 capacitors right here, are in series. Look, there's no junction in between. I know there's a bend, but a bend is not a junction. A bend is just a bend. You have to have where one wire splits into 2 or more wires. Okay? So here, what is a 10 and 10 in series? We haven't seen that before. Well, it's 1 over a tenth plus a tenth. That's 1 over 2 tenths, which is 1 over a fifth, which is 5. So I have a 5, a 3, and a 2. That's 10, right? Mm-hmm. And a 10 and a 20. Let's see, instead of making this 100 volts, let's make it 12 volts, because it's an easier number to work with. So my final circuit is going to be a 20 microfarad and a 10 microfarad. Now, I can find the equivalent, and I can find the charge on them, but 10 and 20, they just don't add up very easily. I got to pull up my calculator and do a little fraction reduction. But I don't really need to do that, because I really just want to know what are the voltages. What's the voltage on the 10 microfarad? The smaller capacitor is going to be 8 volts. Right. The smaller capacitor has 8 volts. It's smaller by a factor of 2. And this one is going to have 4 volts. The bigger capacitor has the smaller voltage. I'm almost done, really, because I have 4 volts there. I have 8 volts, 8 volts. And on the 2 10 microfarad capacitors, I'll have 4 volts and 4 volts. So that looks like a complicated circuit. But once you begin to simplify it just a little bit, then it begins to all fall into place. And you should find that on the test when you do the circuit, when you do the combination circuit, that it will all fall into place just as soon as you begin to simplify it.
So 30 divided by 12 yields how many microfarad?
Well, it's not 30 though, because a 10 and 20 in series is not 10 plus 20. It's 1 over 10 plus 1 over 20. I mean, let's see, 1 over 10 plus 1 over 20. What's that, like 20 over 3? So it's 6 point something. 6 and 2/3. Yeah, 6.7. And so I don't know. I mean, the charge here, Q, would equal to CV. So that's 80 microcoulombs. 80 microcoulombs. I guess that works out okay. All right. Oh yeah, because the 3 cancels out, so it's 20 times 4. Okay. That would be a good test question, something like that. Y'all feeling a little more comfortable? Don't want to be here on a Friday afternoon. Okay. Yeah, but the test isn't for a couple of weeks. So easy peasy on this one. This is a low ball. Voltage here. Huh?
I thought you were at it.
Oh yeah, another 12 here. 12. What about here? 8. 4. Now what's the equivalent capacitance? I know these two are 2, 2, 6, and 4 is 12. Yeah, so the equivalent is 12 because this is 2 microfarads. This all combined, the equivalent is 2 plus 6 plus 4. That's equal to 12. And then my voltages would be 12 volts, 12 volts, 8 volts, and 4 volts. That wouldn't be a free response question. That would be a multiple choice question. I would give you that circuit and ask, what is this voltage? Or what is the charge? Or something like that. The charges, by the way, would be 24, 24. Notice they're in series, so they have the same charges. 72, and 48. That was too easy. Let's do this one. All right, this is on page 12. I'm going to start here, and I go in this direction. Notice my first junction's right here. It's got 2 distinct parallel branches. And then they come back together right here. And then it's in series with that one. And then it splits up again. I have 2 distinct parallel branches. And then it comes back together again and goes back to the battery. So the way that I would draw this is I would have a 2 and a 4. And then I would have a 4. And then I would have a 4 and a 4. Let me sort of fix this. And then in parallel with a 10, I'll write in the numbers here. So this is 2, 4, 4, 4, 4, and 10. All 12 volts. Okay? So this is going to be 6 on the left, 4 down here, a 4 and a 4 in series is just 2. 1 over a quarter plus a quarter is 2. And then added to a 10 would be 12. So these two would be 6 microfarads. This would be 12 microfarads. And then this is a 4. So my final circuit, or sort of the next to last step, is going to be a 6, a 4, and a 12. And let's do that. That's another common combination that I like to use. What is that? That's 2 twelfths plus 3 twelfths. That's 6 twelfths. That's equal to 2. So the final circuit has an equivalent of 2 microfarads over 12 volts. That means that every capacitor has 24 microcoulombs, right? 2 times 12. So I get 24 microcoulombs here, 24 microcoulombs here, and 24 microcoulombs here. So then my voltages, which are Q over C, 4 volts, 6 volts, 2 volts. Which jives with what I know, that the big capacitors have a small voltage, small capacitors have a big voltage. Notice the 4 microfarad has the biggest voltage, the 12 microfarad has the smallest voltage. And then they all add up to equal to 12 volts, 4 plus 6 plus 2. And then I'm almost done, right? I got 6 volts here, 4 volts, 4 volts, 2 volts, and what across these two 4 microfarad capacitors? 1 volt and 1 volt. That's 4, 4, 6, 1, 1, and 2. And then if I asked the charge, you would just take the product. So 8 microcoulombs, 16 microcoulombs, 24, 4, 4, and 20 microcoulombs on all those different capacitors. That's another good test question. Like that kind of difficulty is what we're looking at for the free response. That's a great one. Okay? Y'all could do that. Could you do it right now, you think? Maybe? With no pressure? Or you just sort of for fun? Like you're just doing it for fun? Yeah, right.
So how was 4 volts distributed?
4 volts. What do you mean? Whereabouts?
Like for 2 and 4 microfarad.
Right here?
Yeah.
Yeah, so this 4 volts came about because I know that I have 4 volts on this one. This is the equivalent capacitor to these two, right? 2 plus 4 is equal to 6. But I got the 4 volts because I know that on these equivalent capacitors I have 24 microcoulombs. And these have 24, 24, and 24 on all 3 of those because they're all in series. They all have the same charge. So they all have 24 microcoulombs. And then I use that charge, and then I also have, you know, the capacitance right here to find the voltage. V is equal to Q divided by C, 24 divided by 6. And then once I got this 4 volts, and I say, that's the equivalent of this branch. They're in parallel, so they're both going to have the same voltage, 4 and 4. Okay? Let's do 1 or 2 more. Let's find some good ones here. What is 3, 6, and 2? Is that 2 or 1? It's 1. Oh, that's not very good. Let's not do that one. Oh, we've done one similar to this. Is it 2? It's 2, isn't it? Let's forget. 1 over a third plus a 6 plus a half. I think I changed this one. These all came from old exams. Oh no, we can do this one. Let's do this one. This one's a little bit easier. That's equal to 1. So this equivalent is 1. And so my final circuit is going to be 4 microfarads and 2 microfarads. I got the 2 because I have this 1 and I added it to that 1. 4 and 2. I could find the equivalent. 1 over a quarter plus a half. Is that like 1.3, I think? But I don't really need to because I know this is 12 volts. So on the 4 microfarad capacitor, it's going to be the smaller of the 2 numbers. It's going to be what? 4 volts and 8 volts. So that means that I have 4 volts here, 8 volts here, and then across these 3, I have 8 volts. Now, I know those 3 are 1 microcoulomb, or 1 microfarad, so I'm going to have 8 microcoulombs here, 8 microcoulombs here, and 8 microcoulombs here, which means that I'll have, what is V? Q over C? I'll have 8/3 volts, 4/3 volts, and 4 volts. Those do add up equal to 8. 8/3 plus 4/3, that's 12, that's 4 volts plus 4 volts. So those all add up to 8. You'll see what I did there? I know the equivalent capacitor here, and I know the voltage because of the way the voltages are split up. So I have C times V, 2 times 8. I have, no, I'm sorry, that's not it. I come up here, I know I have 8 volts across this. And so I know the equivalent of these 3 is 1 microfarad. So I have 8 microcoulombs, 8 microcoulombs, and 8 microcoulombs. Because on the 1 microfarad equivalent capacitor with 8 volts across it, I have 8 microcoulombs. Okay? We do one more, then I'll let y'all go. Or if y'all want to do more, that's fine, but you look like you're not into this. It's sort of depressing me.
It's just a lot to take in. It's moving so fast.
I understand. Yeah, but it's good to get as much practice as you can.
It's like my head's like my head is for a second on the YouTube loading screen.
I understand. But you should go back and practice these on your own. And if you forget sort of how I work through these, then you can look at them again. I want to look for a more difficult one. This is a lot like one that we've done, but it's similar, but a little bit different, I think. So, start right here, go through. I don't get a junction until I come up here, and then I split into 2 pieces. And then it comes back together again, and then I get another junction with 2 pieces in it. So my circuit's going to look like this. I have my 12-volt battery. There's my 3 microfarad. And then I come into a 2-piece circuit. Let's draw it up and around. Like this. It's going to come back together, and then I'll get another. Like that. So this is 3 microfarads. I've already drawn it. This is a 1 microfarad, a 3, and a 6 microfarad. And then I have 2, 2, and 2. All right? This top branch right here is a 1 with a 2. So that's 3 microfarads. So if I redraw this, I have a 3, another 3, hold on, and then another 3 microfarads. Yeah?
So when you're looking at a graph like this one, test,
Mhm.
tell from a junction to
A junction is going to split into multiple parts. So if I come here and I go around that turn, look, it doesn't split into 2 parts. But a junction, on the other hand, you come and then you split into 2 or more parts, 2 or 3. You'll never have more than 3 branches in a parallel circuit. I know that it looks the same. You're not the only one. That other students, they see this and they say, ah, that's parallel. But it's not. That is not in parallel. That's not the beginning of a parallel branch. Not until I get over here do I get the beginning of a parallel branch. The trickier part is this. Like, what do I do with this? And I just think about, I can slide these. It looks like I have 2 junctions right here, but they're connected by a wire. So it's like I can slide the 2 junctions together so that they make something like this. And I can do that because there are no capacitors along this wire. I can slide those junctions together so that they just combine 1. And people do that. They draw their circuits that way just because it makes them easier to print on a page rather than printing them like this. This gets kind of complicated. So from here, I know I have 3 identical capacitors. By the way, the equivalent is 1. That's another common combination. 3 3s is equal to 1 microfarad. So I have 4 volts, 4 volts, 4 volts. That's 4 volts there, 4 volts there. I have 4 volts across these 2, which is going to be 8/3 and 4/3 split up. We'll see that in a second. And then I have 4 volts here, 2 volts, and 2 volts, because it splits up that 4 volts into 2 equal pieces. And then the only part that I have left is I have that 3 and 6 in series with one another. And I know that across both of them combined, I have 4 volts. Well, the 3 and the 6 is a 2 microfarad with 4 volts. So it has 8 microcoulombs, 8 microcoulombs there, 8 microcoulombs there. And then my voltages will be 8/3, 8/3 volts, 8/6, 4/3 volts. So I'd have 8/3, 4/3, 4. This is 4. This is 4. 2, 2. Those are all the voltages on all those capacitors. Another good test question. That difficulty is what we're shooting for. All right, you're looking at about 6 or 7 capacitors, variety of parallel and series. Again,
The questions could be asked, what is the net charge for each capacitor?
yeah, I'll just ask you the voltage or the charge on a couple of the capacitors.
Yeah, like it's not gonna be for all of them, but just only for one, right?
No, but you can't really find one without finding all of them. In fact, you really should just get in the practice of finding all of them because it allows you to find out if you have problems. So, like for example, if these voltages here don't all add up to 12, then I have an issue somewhere in the way that I've done what I'm doing. Or if these voltages don't add up to 4, then I've done something wrong. So you always want to check for those consistencies. Yeah, if you find 2 or 3 of the voltages, you might as well find them all. Okay? Any questions? I appreciate y'all coming. It is good for you to get this X in there.